Hello everyone and welcome to another episode of Java Basics. Today we're going to be talking about logical operators, in other words, and, or, and not. So let's get started with an example.
If you want to learn Java programming, or just programming in general, subscribe to this channel. We put out a lot of videos that range from beginner topics to more advanced programming concepts. Also, please like this video, share it with a friend, and write a comment as well. It goes a long way to help promote a channel like this. Now, let's get back to the video.
Here we're going to try and write code that will print the price of a movie based on this condition. If you're under 12 or over 50, it's a cheaper ticket. Otherwise, it's $12.50. Let's head over to NetBeans and see how we can get this done. First, we start with our variable, and we'll start us at 30 years old. Now we do our conditional. Okay, let's test this out and make sure it works. We're 30 years old, we would expect $12.50. And there it is. Of course, if we're 3 years old, $7.50. And if we're 333 years old, the price of the movie is still $7.50, but I think you're going to need a little bit more help than just paying $7.50 and getting a little bit of a discount if you're this old. Anyway, this program seems to work. But the problem here is you can see we've duplicated code. We have the exact same line of code here as we do here. And we don't like that. So let's see if there's a better way. We're going to use something called a logical operator. The logical operator is either and, or not. In this case, we're going to use or, because what we want to check for is if the person is under 12 or the person is over 50. And if either of those is true, we want the price to be $7.50. Now in Java, the logical or operator is used by two vertical bars next to each other. We have a Boolean expression, age less than 12, followed by our or operator, followed by age greater than 50. Let's see how this works in NetBeans. So we no longer need this. We're going to combine less than 12 and greater than 50 in one statement using our or operator. As you can see, we no longer have duplicated code. It's a lot shorter. Here what we're doing is we're checking to see if the age is less than 12 or the age is greater than 50. If either of those is true, $7.50, otherwise $12.50. Let's just double check. If we're 333 years old, we should now get $7.50. And if we're 33 years old, we should get $12.50. Perfect. As you can see, one of the benefits of using a logical operator in Java is so we can combine conditionals. Speaking of conditionals, why does a computer programmer put two glasses next to his bed at night, one full and one empty? Well, the full one is just in case he gets thirsty. The empty one is just in case he doesn't get thirsty. Let's take a look at the truth table for an OR operator. So we have two conditions, P and we have Q. P is going to represent inside the box we have a red circle. Q is going to represent the statement inside the box we have a blue square. Now, in this situation, both P and Q are true. So what's the value of P or Q? Putting these two sentences together, we would have inside the box we have a red circle or inside the box we have a blue circle. Well, that's a true statement. Now let's take a look at what happens if P is true and Q is false. Now we have a situation where P is true and Q is false. Inside the box we have a red circle, that's a true statement. Inside the box we have a blue square, that's a false statement. So what about P or Q? Inside the box we have a red circle or inside the box we have a blue square. Well, if I said that to you, I would be telling you the truth, because we do have a red circle inside the box. So P or Q is true. Now let's take a look at the situation where P is false and Q is true. Do we have a red circle? No, P is false. Do we have a blue square? Yes, Q is true. So what about the statement, inside the box we have a red circle or inside the box we have a blue square? Well, that's a true statement because I use the OR logical operator. So therefore, P or Q is true. Now, what about the situation where they're both false? If I come to you and say, inside the box, we have a red circle, or inside the box, we have a blue square, I would not be telling the truth. Neither of those statements are true. Therefore, P or Q is a false statement. This is called a truth table. It shows every single possibility for the first statement and the second statement, the combination of the two, and it shows you what the OR operator would result in. All right, now it's time for a secret club. You're allowed to get into the secret club, but you have to be at least 21 years old and your first name must start with the letter M. And of course, we're only going to handle capital M's because Java is case sensitive and we don't want to overly complicate this program. Now, how are we going to do this? Luckily, in Java, we not only have an OR operator, but we also have an AND operator. And we do that by using the ampersand key twice. So here is what it will look like. If our age is greater than or equal to 21, and the first letter of our name is equal to capital M. Let's head over to NetBeans and see how this looks. So first we'll start with our age. We'll make us 30. And then we'll move on to our name, Joe. And we need to get the first letter of our name. Remember, substring starts at this position, 0, which is the first letter, and it goes up to but not including this position. So we start at the first letter, J, and we go up to but not including the O. So that's how we get the first letter. And now let's do our conditional. All right, let's test this out and see how it works. In order for us to get in, we have to be at least 21, and we have to have our name start with M. Well, this person doesn't meet that criteria, therefore, we cannot enter. Let's say our age is 3 and our name is Joe. Well, we still can't enter because we don't meet the criteria. What happens if our age is 3 and our name is Mary? Well, again, we don't meet the criteria. Our name begins with an M, but we're not 21 or over. But if Mary happens to be 30, now she meets both criteria and she can enter the club. Let's take a look at the AND truth table. So again, we have a box with a red circle and a blue square. The P statement represents inside the box we have a red circle. The Q statement represents inside the box we have a blue square. At this point, both of them are true. Therefore, the AND statement, which would be inside the box we have a red circle and we have a blue square. That's a true statement. However, what happens if the first statement's true and the second statement is false? If I go up to you and say, inside the box we have a red circle and a blue square, I'm not telling you the truth because we don't have a red circle and a blue square. Therefore, the AND statement is false. And the same thing would hold true if the P statement was false and the Q statement was true. Inside the box, we have a red circle and a blue square. Well, that's not a true statement. Therefore, the AND logical statement is false. Of course, if both of them are false, and I tell you inside the box we have a red circle and a blue square, I'm certainly lying to you. Therefore, the AND would be false. Okay, let's try some examples. I've put up 10 problems. Here are the values. A is 1, B is 2, C is 3. Pause the video for a moment and see if you could determine whether or not each of the 10 statements will evaluate to true or false. All right, let's go over them. Here are the answers. Did you get them all? Notice I've circled one because that one may be a little bit confusing. Why is number 10 true? That doesn't make any sense. Well, before we get into that, first think about this question. What is 1 plus 2 times 3? Now, if you're going left to right, you would probably say that the answer is 9. 1 plus 2 is 3, times 3 is 9. But that's not the way math works. Math has an order of operations. First we do multiplication, then we do addition. So the answer to this is not 9, it's actually 7. 2 times 3 is 6, plus 1 is 7. Java also has an order of operations when it comes to logical operators. The OR logical operator is similar to addition. The AND operator is similar to multiplication. Therefore, the AND will get evaluated before the OR because it follows normal PEMDAS order of operations. So in this case, first we evaluate C is equal to 3. That's a true statement. C is equal to 3. A greater than 4. That's a false statement. 1 is not greater than 4. We have true and false. That all gets evaluated first, and the result is false. Now we do the other part. 0 less than B. That is certainly a true statement. B is 2. So we have true or all of this, which really boils down to true or false. And that value is true. That's why number 10 evaluates to a true result. Now, if you do want this piece to be evaluated first, the OR part, what you have to do is add parentheses. And there they are. Let's head over to NetBeans and see how this looks. So here you see I have no parentheses. I just have the entire logical statement, and this should evaluate to true, as we saw. But if I want the OR to happen first, I'm going to add parentheses here and here. And now it should evaluate to false. Now, one other thing I just want to point out, we can print Boolean values. This evaluates to a Boolean, true or false. So if I print it, it's just going to print true or false. Now, when Java is evaluating logical statements, it takes some shortcuts. Java does something called short circuit evaluation. Let's see what that means. So consider that you have to figure out whether or not the following statement is true. There are exactly 48 Italian restaurants in Queens, New York. Now, you're not allowed to use the internet. You're not allowed to ask anybody. The only thing you can do is walk around and count for yourself. How long do you think this will take? Of course, it's going to take a really long time. Queens is a big place, and you have to walk all over Queens. You can't just walk around and find 48 restaurants and then say, okay, I'm done. Because this statement is saying there are exactly 48 Italian restaurants. So you have to go to every single restaurant in Queens and see if it's Italian, and then you have to count them. That's going to take a really long time. However, consider whether this statement is true or false. 2 plus 2 is 5, and there are exactly 48 Italian restaurants in Queens, New York. Now, how long do you think this will take? I'm going to say that this is going to be a lot shorter. It's going to be a lot easier to figure this out. And here's why. We already know that 2 plus 2 equals 5 is false. And we know that if we have a false statement and anything, it's going to result in a false statement. The AND operator needs both things to be true. In this case, we already know the first one is false. Therefore, this entire thing is a false statement. Because the first part is false, it is irrelevant what is written here. Whether there are 48 Italian restaurants in Queens, New York or not, doesn't matter. Because this first part is false, the entire statement is false. Now take a look at another example. 2 plus 2 is 4, or there are exactly 78 Japanese restaurants in Queens, New York. Again, the right side of this is going to take you a really long time to figure out. But luckily, we don't have to even get there. Because with an OR statement, if either part is true, the entire statement is true. And we already know that the first part is true. So because the first part is true, we can ignore the task set for us in the second part and short circuit this statement and not even evaluate it. It's irrelevant. Now, how does this relate to Java? Well, in Java, we have this if statement. And inside the if bracket, if we have an AND logical operator, it will be condition 1 and condition 2. If Java sees that condition 1 is false, it's not even going to evaluate the second condition. It's going to ignore it. Similarly, if we have an OR statement and the first condition is true, Java is going to say, well, the entire statement is going to be true, therefore I can ignore the second condition. Okay, let's take a look at this and see if it will work. Pause the video and come to a conclusion on what this will print or whether there will be an error. Okay, there will be an error. But you may think, why is there an error? Look, we're checking to see if y is greater than or equal to 0. We know that we can't divide by 0, so that's why when we do x divided by y, we have to check to see if y is greater than 0, and we are. So why will this generate an error? Let's head over to NetBeans and see why. So here's the code. Let's just double check to make sure that we have this error, and we do. Arithmetic exception, divide by 0 at line 7. Right here, we're dividing by y, and y is 0. So again, why is Java not considering that we're checking to see if y is greater than 0? And that's because Java goes left to right. First, it evaluates this division, then it will evaluate greater than 0, and then it will combine them with the and. So when it evaluates the division, it gets this error, and here you go. How can we fix this? Well, let's switch the order of these two statements. Y greater than 0 and let's see if this works now. And it does. Fantastic. Why is this working? Well, because Java is short-circuiting the right side of this AND statement. Here we have y greater than 0. This is a false statement. Because it's a false statement, Java knows that AND will evaluate the false. It ignores this, so we don't get an error. Java also has a not operator. Now, we saw this briefly in one of the prior videos. The not operator is an exclamation point. And what that does is it switches the value of a Boolean. So if a Boolean is true, the not operator switches it to false. If the Boolean is false, the not operator switches it to true. Here's an example. We have a Boolean variable has 1. We're setting it equal to true. And our conditional says if not has 1. In other words, if this is false, then we print I lost, boo-hoo. Otherwise, we're going to print I won, yay. Let's head over to NetBeans and see how it works. Has 1 is true. Let's run this. We're checking to see if we have not won. This is a true statement. Therefore, when we invert it, we get a false statement. Therefore, we fall to the else and print I won, yay. If this is false, again, this will be a false statement. When we not it, it will be a true statement, and we will go into this section and we will print I lost. Let's take a look at the truth table for not. This one is a lot simpler. The statement P is there is a blue square in the box. Right now the statement is true. Therefore, not statement is false. There is not a blue square in the box. What happens if P is false? There is not a blue square in the box. Well, if I say that to you, I'd be telling you the truth. Therefore, not P is true. Now, something that's important to know, when you're doing a decision like this, an if statement, and you want to check to see if has 1 is true or false, if you want to check to see if has 1 is true, you could do it like this. If has 1 is equal to true. But because this is a Boolean already, this statement has to evaluate the true or false. This already is a Boolean that's true or false, so you don't actually need this piece. You could just check if has 1. This already evaluates to a Boolean. Similarly, if you want to check to see if this is false, you could do this. If has 1 is equal to false. But again, this statement is a Boolean. This is already a Boolean. So you don't have to do this code here. You could simply just not has 1. And that works just the same. So what does this statement mean in English? Not A greater than B. It means that it is not true that A is greater than B, or A is not greater than B. But really, that just means that A is less than or equal to B. So there are ways to simplify statements that contain the not operator, especially when you're using greater than or less than. Here's the example that we already saw, but here are some other examples. Not A greater than or equal to B. That means that it is not true that A is greater than or equal to B. Therefore, A is just less than B. Similarly, it is not true that A is less than B. A is greater than or equal to B. Here, it is not true that A is less than or equal to B. Therefore, it just means that A is greater than B. So these are ways to simplify your statements if you want. Now, the not operator actually takes precedence in the order of operations over both the and the or. So for example, code like this You may think that you have to do the or first, but that's not true. What happens is we're going to do the not operator first. So we're going to evaluate a less than 6. That's a true statement. Then we negate it because we have this not operator. This is now a false statement. B is equal to 7 is a true statement. And when we OR them, we get true. Let's head over to NetBeans and make sure this is correct. Here it is. This is a true statement, as we saw. Therefore, we should print the letter A, not the letter B. And there it is. All right, let's try something a little more complicated. Complete the following truth table. Pause the video for a second and try and figure out what every single box will be. Okay, here we go. A and B. Now remember, an and statement means that both have to be true in order for the entire and statement to be true. So both of them are true here. Therefore, this is a true statement. However, at least one of them is false down here. Therefore, these all evaluate to false. Now, in this column in red, what we're doing is we're taking not A and B. In other words, the opposite of this column. And that evaluates to these values. All we did is take the opposite of these. Now let's take a look at something else. What is not A? Well, not A is the negation of this column. Therefore, if it's true, it becomes false, and so on. Similarly, not B is the negation of this column, and here are the values. Now let's take not A, which is this column, and OR it with not B, which is this column. Now remember, in an OR statement, either one or the other has to be true. If they're both false, we get a false result. However, here, one of them is true, one of them is true here, and here both of them are true. Therefore, the OR statement evaluates to true. Compare the two columns in red. Notice they're exactly the same. Not A and B is the exact same, it's logically equivalent to not A or not B. And that's called DeMorgan's law. Not A and B is the same as not A or not B, and similarly, not A or B is the same as not A and not B. Now, we can use this law to simplify complicated compound Boolean expressions as follows. Here's an example. Let's say we have this statement in our program. We have age greater than 12 and age less than 20. This means the age has to be between 12 and 20, but then we're taking not. So how do we simplify this? Well, first, we can rewrite this as not age greater than 12 or not age less than 20. That's using DeMorgan's law. We not this, we not this, we change the and to an or. Now we can finally change it to this. Age greater than 12 inverted really means age is less than or equal to 12. Age less than 20 inverted really means age is greater than or equal to 20. So this statement, which had a not in it, which is honestly a little bit difficult to look at and read, can be rewritten as something much simpler. The age has to be less than or equal to 12, or the age has to be greater than or equal to 20. Let's practice. Pause the video and see if you can figure out what a simplified version of this would be. Now notice I did not use the Java symbols. I'm using just English symbols, not and and. Okay, let's break this down. The first thing we're going to do is we're going to take this not and we're going to kind of distribute it over to here and over to here. So let's do that. Over here we get not greater than or equal to 160. And over here we get not less than or equal to 231. But when we do this, DeMorgan's law says that we have to switch the and to an or. So our new statement is not greater than or equal to 160, or the weight is not less than or equal to 231. We can simplify each one of these pieces as follows. If the weight is not greater than or equal to 160, That just means that the weight is less than 160. Here, if the weight is not less than or equal to 231, all that means is the weight is greater than 231. We still have our or statement. And now our simplified logical statement says you may not fly as an Air Force pilot if your weight is less than 160 pounds or your weight is greater than 231 pounds. In my opinion, this is a much simpler statement to work with than something that involves not.
I hope you learned something from watching this video. Please remember to subscribe and share this video with others who are learning Java programming. Thanks for watching, and take care, everyone.